Okay, so I think you will have one question in your mind. When we should design some information as the attributes and when we can design as a entity. So one information can be designed as entity should satisfy at least one of the following conditions. If we design the information as an entity beside the name or the key of this entity, it should also have at least one of the non-key attributes. Or we can design this information as an entity instead of attributes if this kind of entity can serve as many sides in a many-to-one relationship or many-to-many relationship. Just like the example we showed before for the beers as well as manufacturers. We can design this manufacturer as an entity because besides the key, the name, it contains one more attribute, the address, right? Because of this reason, we can design the manufacturer as an entity. What's more, for beer, we can design this beer as an entity as well, even though it only contains one single key attribute. However, this beer can serve as many sides in a many-to-one relationship. Therefore, we can also create this one as an entity as well. In this page, we have another example of beers here. Their diagram we can design. In the first diagram, we draw the beer's entity with the name of the beer as well as manufacturing information and manufacturer name. In the second case, we try to divide the attributes of the beers about the beer name and manufacturer name into two entities instead. One is for the beers, another one is for the manufacturers. Then the question will be which one will be good according to our rules we discussed in the previous page. So let's check the first one, first design for the beers. We find that the beer has two attributes. The first one is the name, the second one is the manufacturing information. This manufacturer will be more like the attribute for the beer, right? Given a beer, we can know like some brand for the beers. Then it's fine. If we don't have any other information about manufacturer and the manufacturer address, then this design should be fine. And let's come to the second design. For this design, we may have some problems. So let's see the beers first. For the beers, it has only one single attribute, right? According to our rules in the previous page, we said that for some information, we cannot design them as entities if it only has one single attribute, which is also the key. However, by checking this beer carefully, we find that the beer is on the many side of this relationship manufactured by, right? So given a beer, we can have multiple manufacturers, right? So the beer is on the many side for the relationship. As to the manufacturer information, besides the key, the name, we have no other attributes for the manufacturers. Also, the manufacturer is also on the one side of this relationship, right? According to our rules in the previous page, we cannot design this manufacturer as an entity. It would be a waste of space. Besides the rules we showed before, we also want to use some concrete data to show the difference as well as advantages of these two different designs in our ER model. So for the first case, we have one single entity, the beers. It contains the name as well as the manufacturer as attributes. For the second design, we have beers manufacturer as two entities. They are connected by the manufacturer. This is manufactured by this relationship. The beers and the manufacturer only has one single attribute, which are all the keys. Let's assume if we want to store the data for the first design into tables, we can create one beer's table like this, right? We have beer name and manufacturer name as two attributes. And we can also store some data from our previous example, which are like this, right? We have Bud and Bud Light, the manufacturer of the Bush, right? This design is very concise. And let's take a look at the second design. For this design, we have to create three tables. The first one is the beer, the second one is the manufacturer, the third one will be the relationship manufactured by, right? For the beers, we have one single attribute, the beer name, and we have two data instances, Bud and Bud Light. As to the manufacturer, we have one single attribute, and we have one single data tuple, is the Bush, right? And as to the manufactured by relationship, we have to fill in all the information we have in our table, in our database system. We contain the Bud and the Bud Light, as well as the manufacturer names. So by comparing these two designs as well as the data storage in these two designs, we find that the first design can be better and concise in storing the data we have. So the first one will be a better design in this case. You can also compare this case with the previous case we discussed before. In this case, if we have the address for the manufacturers, then the third design will be better compared with the previous two. Right? However, in the case if we don't have any attribute for the manufacturers, then the first design will be more concise, will be better. Hopefully this example can help you understand why we have the rules shown before. And normally when you decide a information should be represented as either an entity or an attribute, we can follow the rules we discussed in the slides. Okay, so the last rule or principle we need to keep in mind in the ER model design is don't overuse the working set. Working set can be very helpful and useful for us to model some of the cases. However, we cannot overuse this working set in our design. There has been a saying that in database design, they can say that we can design everything to be a working set depends on each other. Then in the whole system, we only have the working set, we don't have any owner or any sets. So this design can work in many cases, however this design cannot be good. And they can make all the entity sets to be weak, supported by all the other entity sets together which they are linked. The main disadvantage of this design is that we cannot find a key for the entities in our database systems. In other words, when we refer to some data in our tables, we have to search over all the tables to find a key or to form a key for this entity. This can be very bad. In the real world, normally we want to create some unique IDs for the entities in the real world. Right? So for example, for a person, we want to define his ID to be the SSN number or driver license number or passport number. We want to create the IDs for the information we have in the real world. It's similar for cars, right? We can create a VIN number for cars. Therefore, in the database system, it will be very similar. We want to create an ID or a key for the entities we have in our design. This will be very important. With a key, we can refer to the entities very easily. And then you may wonder when we can use the working sets. Normally, when you try your best to design the keys for the entities, no matter what you try, you can still find a good key for the entity, then you may consider to use the working set. When this happens, it is normally the case that we have no global authority capable to create a unique ID for this kind of entities. And we have an example at the bottom that it is unlikely that we can have an agreement to assign a unique player number across all the football teams in the real world. Like if we say the number 10, a football player in the real world, who are we referring to? Because in the real world we have so many players with the number 10, right, on the team clothes. It is hard to distinguish each other, right, by the numbers. The number alone is not enough. Therefore, for this kind of case, we may consider to combine numbers with the team name as well as even the time of the team, so we can differentiate the players from each other. And we can make the player as a working set depends on the teams, right? Therefore, you need to think about it. Don't overuse the working set in our design, and this can be very important. Okay, so in this page, I'd like to draw a summarization about this section on the ER model. So you need to know why we need to learn the ER model, the motivations, right? The main reason is because the ER model is the beginning step for us to model the real world in our database systems. So with the ER model, we can know the information to be modeled, to be included in our database systems, as well as some constraints on these kinds of information. We will show the history of the ER model. This ER model was proposed by Peter Chen in his paper, right? And you can also refer to that paper if you have time, and you can find the paper online. So in this section, we also introduce some basic structures we can use to draw the ER model. We show how to draw an entity, attributes. We also show how to draw some relationships, which can be binary, multi-way. We can also convert a multi-way into binary as well. And we show some constraints on relationships, one-to-one, one-to-many, and many-to-many. We also know these attributes on relationships. These relationships can be connected to different kinds of entities. They can be even connected to one single type of entities, like the reports to we showed before, right? An employee can report to some other employees. denoting some can be the supervisor, some can be the subordinates. Where children is a, the triangle denotes a spatial relationship among entities, subclass. Right? Besides the basic structure, we also show some constraints on both relationships as well as entities. So on the relationship, we need to pay attention to the constraint like one-to-one, one-to-many, and many-to-many. We also mention some other constraints like keys on entities, and how to represent them in the ER model. We also talk about the referential integrated constraint and how we represent them, as well as some other constraints. We spend lots of time on talking about these organic states, how to choose them, and when they will be needed. And at the very end, we show some basic design principles we need to follow. So in our ER model design, we need to be faithful. We need to avoid redundancy. We should also don't overuse this organic state in our design. So generally, that's it for this section, and you can go over this section very carefully. Then you can work on your homework. In the next week, we will move to the next section on the relational model, which will be also very important. And everything we design here will be translated into relations. We will show how to do the translation for you in the next section. Thanks again for your attention in this section. Bye-bye.